Welcome to our channel Sankalp Study Success. In this video, we are going to learn how to convert given deterministic finite automaton to a regular expression. That means this conversion is we are going to learn using Arden's theorem. This Arden's theorem will make us easy to convert DFA to regular expression. So now let us see what is Arden's theorem and how are we going to convert DFA to a regular expression. So here, if you consider P and Q as the regular expressions, there are two regular expressions P and Q. So here, if R is equals to Q plus RP, that means your regular expression, it is of the format Q plus RP. Then the solution for this regular expression will become R is equals to QP star. So this is the solution for the R is equals to Q plus RP regular expression. So this is the most important point which we need to remember in order to solve the problems of Arden's theorem. The question may be using Arden's theorem, or the question may also come as convert the given DFA into regular expression. So here you can also refer to this note which is given at the left side, because whatever is explained here is already given in the notes in detail. And also now let us solve a problem and let us know how to convert DFA into a regular expression using this point, which is the most important point, where if your regular expression it is of the format R is equals to Q plus RP, then your solution will become R is equals to QP star. So here you need to find the regular expression for the given deterministic finite automaton. So in order to find the regular expression, we are going to write the regular expressions for each and every state present in the DFA. That means there are 4 states Q1, Q2, Q3 and Q4. So for each and every state we are going to write the regular expression. That means whatever the input symbols are coming to this state are written as the regular expression. That means for Q1, 1 is the intake and also 0 is the intake, and also there is another intake which is epsilon, that because it is of initial state. So for Q1 we are going to write from Q2 we are getting 1, so that means 1 Q2, and from Q3 we are getting 0, that means it is 0 Q3 and plus epsilon, which is nothing but it is an initial state, so we are adding epsilon as well. So this is for Q1. And for Q2 there is only one intake 0, that is from Q1, which is 0 Q1. So there are no more states we are getting any inputs to the Q2. So we are going to take only one, which is 0 Q1. And for Q3, if you see, we are getting only 1 from Q1 and nothing is coming from any other state. So Q3 is equals to 1 Q1. And for Q4, 0 and 1 are coming to Q4 and also 1 is coming to Q3. So that means 0 Q4 plus 0 Q4, 0 Q4 plus 1 Q4, right? So 0 Q4 plus 1 Q4 plus 1 Q3. So 0 Q4, and also we are getting 0 from Q2, so plus 0 Q2. So 0 Q4, 1 Q4, 1 Q3 and 0 Q2. So like this, for each and every state we are going to write the regular expressions. Now we are going to solve the regular expression for only the final state in order to get the regular expression for the given DFA. So here the final state is Q1. So here final state is Q1. So for this Q1 we will take, let us consider this as equation 1, and now in equation 1 you need to substitute Q2 and Q3, right? Because this equation has Q2 and Q3 variables. So now substitute Q2 and Q3 values in equation 1. So what happens? What is equation 1? Q1 is equals to 1 Q2 plus 0q3 plus epsilon, right? 1q2 plus 0q3 plus epsilon. Here q2 is nothing but 0 q1. So here q1 is equal to 1 is as it is, and q2 is nothing but 0 q1 plus 0 is as it is. What is q3? 1 q1. So 0 1 q1 plus epsilon. This is our q1. So now if you take q1 as common from RHS, that means we will get 1 0 plus 0 1 of q1 plus epsilon. So now if you observe, it is in the form of R is equals to PR plus Q, right? That means Q plus RP, that is R is equals to PR plus Q. Now, what is the solution for R is equals to PR plus Q? The solution is nothing but R is equals to QP star. So, from this, let us write what is P, Q and R. So, R is equals to Q1, P is equals to 1, 0 plus 0, 1 and Q is equals to epsilon. So, these are the values from the equation which we got previously. So the solution becomes R is equals to QP star. That means R is equals to Q is nothing but epsilon and P is nothing but 1 0 plus 0 1 whole asterisk. This is our regular expression for the given deterministic finite automaton using Arden's theorem. That means using Arden's theorem we are converting DFA into a regular expression by considering each and every state and also writing the regular expression for each and every state. So for every DFA we are going to take the regular expression. You have to convert it in the format of R is equals to PR plus Q, so that the solution becomes R is equals to QP star. So in this way we are going to solve the problem. Now let us see one more question, which is find the regular expression that represents the following DFA. Here we are having 3 states. So we have to write 3 regular expressions for each and every state. So now let us write it for A, then B and then C. So for A is equals to, here the intake is for 0A plus it is also from C which is 0, that is 0C, and now it is an initial state, that means we have to also take epsilon, that is epsilon. Now we are going to write the regular expression for B. Here it is having an intake of 1A plus it is having an intake of 1B plus it is having an intake of 1C also, and that's it. All the intakes have been done. Now we are going to write the regular expression for C, which is we are taking an intake of 0. C is equals to 0C. Sorry, from B, right? Because C is equals to 0B. So these are the 3 regular expressions for the 3 states. Now the final state is A. So we have to consider the final state, which is equals to A. Now we have to solve the regular expression for A. In order to get the regular expression for A, we have to get what is C. So here for C, you have to get what is B, right? So now let us solve B equation. Solve equation B. So in order to solve equation B, B is equals to, what is B? 1B plus 1C plus 1A, right? So 1B plus 1C plus 1C plus 1A. Now here, if you see, if you consider here, if you consider A, then if you consider C, then it is 0B. That means it becomes 10B. So here let us write B is equals to 1B plus 10B plus 1A. Then it becomes, if you take B as common, it becomes 1 plus 10 of B plus 1A. That means you can say it is of the format R is equals to PR plus Q. Right? Here R is nothing but B and P is nothing but 1 plus 10 and Q is equals to 1A. That means here your equation becomes R is equals to QP star, right? From this equation, the solution becomes R is equals to QP star. So our solution becomes B is equals to 1A of 1 plus 1 0 whole star. So you got the value of B. Now substitute this value of B in equation C, that is 0B. So it becomes C is equals to 0B. So if you substitute the value of B, then it becomes 0 1A of 1 plus 1 0 whole asterisk. This is our C value. So from here, we have to substitute C value in equation A. So let us write equation A as A is equals to 0A plus 0C plus epsilon. 0A plus 0C plus epsilon. So now let us substitute value of C here. That means it becomes 0 1A of 1 plus 1 0 whole asterisk plus epsilon. So here if you take A as common, it becomes 0 plus 0 1 of 1 plus 1 0 whole asterisk of A plus epsilon. So here it is of the format R is equals to RP plus Q. Then the solution becomes R is equals to QP star. So here if you take R value is A and P, this is the P value, and Q value is epsilon. So here our solution becomes A is equals to 0 plus, oh here one more 0 will come, right? Because it is 0 1A, that means here we'll add one more 0. So that is 0 plus 0 0 1 of 1 plus 1 0 whole asterisk of, which is epsilon of P star, right? Because here it is epsilon of P star. That means here you can also write it as A is equals to 0 plus 0 0 1 of 1 plus 1 0 asterisk whole asterisk. Even if you don't write epsilon, then also your answer is correct. So that means if your regular expression for the final state is not in the format of R is equals to RP plus Q, then you need to convert your given expression into R is equals to RP plus Q, so that the solution becomes R is equals to QP star. So in this way we are going to solve the problems of Arden's theorem. As it is most important, you can also try these questions. You have to convert this regular DFA into the regular expressions 1, 2 and 3 questions. If you have any doubts, then you can put it in your chat box, or you can also mail to us. So thank you for watching the video.